The next problem says, let f be the function defined on the closed interval from -5 to 5. The graph of the derivative consists of two semicircles and two lines as shown below. So we are given the graph of the derivative. So this is important because remember, if we're looking at the derivative, anything above the x-axis, that means f is increasing. Anything below the x-axis, that means f, my original function, is decreasing because we're looking at the graph of the derivative. So part A says from -5 to 5 on my interval for all values of x, find all values of x which f has a relative maximum, and justify my answer. So I know f has a relative maximum if my derivative is equal to 0. Okay. So that is the same thing as saying the x-intercepts, because when, right, f is another word for y, so when y prime is equal to 0, that's the x-intercept. This is f prime, which is y prime. So we're looking at my graph. So where are my x-intercepts? My x-intercept is right here, right there, here, and here. So where are my relative maximum? So notice that I'm going above the x-axis here. So my function is increasing here. Notice that from -3 to 1, it is below the x-axis. So my original function is decreasing in this interval. From -1 to 4, I'm above, so I'm increasing. And from -4 to 5, I'm below, so I'm decreasing. So as we do a number line, it kind of makes it a little bit easier to see. We have -5, -3, 1, and 4. These are all my critical points. Okay, those are critical points of f. So I'm positive here, I'm increasing. My derivative is negative there, so I'm decreasing. My derivative is positive here. The reason it's positive is because it's above the x-axis. So when my x value is 2, my derivative is positive 2. And then from 4 to 5, I am below the x-axis, so it's negative. So which ones are my relative maximum? My relative maximum is going to occur here, because I'm going from positive to negative, and right here at 4, because once again I'm going from positive to negative. So which ones are my relative maximum? When x is -3 and x is equal to 4. Part B says for -5 to 5, find all values of x which f has a point of inflection. So and it says justify your answer, and your justification would be the same thing, because the derivative changes sign from positive to negative at these points. So that would be my justification. So remember, this point of inflection occurs when the second derivative is equal to 0. So that means I am looking to see where the tangent line of the first derivative is horizontal. So that's where I'm looking at. So as we look back at our graph, notice that at -4, I have a horizontal tangent. I also have a horizontal tangent at -1. And at 2, this is where the second derivative does not are possible points of inflection. So notice that my derivatives, my tangent lines are positive. So I'm positive to the left of 4. My tangent lines are negative to the right of 4. So notice I'm still going down, and then I'm going up again. So I'm at positive, and I'm still positive, and to the right of 2 I am at negative. So all of these are points of inflection. So the points of inflections occur at negative 4, negative 1, negative 2. And that is going to be because the second derivative changes signs at these points. Okay. Part C says find all the intervals in which the graph is concave up. Where it's concave up, where the second derivative is positive. So I already have it from part B. So where is my second derivative positive? It is positive from negative 5 to negative 4. Remember, it's not negative infinity because we start at negative 5. And from negative 1 to 2. Those are the intervals where it's concave up. Why? Because the second derivative is positive in these intervals. The next question says, we're going to approximate the square root of 35 two ways. First, we're going to use linearization, and then we're going to use Newton's method. So let's start with A. We're going to use linearization. So they tell us we're going to use the linearization of y equals the square root of x at the point 636. So remember, linearization is just another way of saying find the equation of the tangent line of y equals the square root of x at 6 equals 36. So to find the equation of the tangent line, the first thing I need to do is I need to take the derivative. So the derivative is going to be 1/2 x to the negative 1/2, or 1 over 2 square root of x. Now I'm not going to set that equal to 0 because I only do that when I'm trying to minimize it, when I'm trying to find the max or the min value or the critical points. So what I am going to do is, since this is my x value, I'm going to go ahead and substitute my 6. So before I substitute, remember that I told you to change this. It should be 36 comma 6, not 636. So if I substitute 36, I'm going to get 1 over 2 square root of 36, which is 1 over 2 times 6, or 1/12. So then, once I have my slope, remember this is the slope of your tangent line, I have to use point slope form to find my equation of my line. So I'm going to have 1 over 12x minus 36 over 12, which reduces to 3. I'm going to add 6 to both sides. So here's my linearization. So I'm going to use that to approximate the square root of 35. So I'm going to say let x equals 35. So my linearization at 35 is going to be 1 over 12, 35 plus 3. And that's going to be 5.917. Remember to always round it off to 3 decimal points. So that's what I think the square root of 35 is. So if we use our calculator to find out the square root of 35, So using our calculator, the square root of 35 is 5.916079. So we're really close, so that's how we can check to make sure that we did this correct. The second way to do this is we're going to approximate square root of 35 by using the first guess of 5 and two alterations of the Newton's method to approximate the zeros of f of x equals x squared minus 35. So remember Newton's method is we need the derivative. Newton's method says that you're going to approximate using the next alteration is x of n minus f of x of n over the derivative. And we only need to do two of these. So x of n, let's write f of x of n, f prime of x of n, and then the minute guess. So they said to use the first guess of 5, and we're only going to do two of these. So as we substitute 5 in here, we get 5 times 5 is 25, and 25 minus 35 is negative 10. That's using x squared minus 35 here. So 25 minus 35 is negative 10. F prime would be 2 times 5, which is 10. So my next guess is going to be 5 minus negative 10 over 10, which is going to be 5 plus 1, 6. So 6 is going to be my next guess. So as I substitute 6 here, I get 36 minus 35, which is 1. If I substitute 6 into the derivative, I get 2 times 6, which is 12. So now I'm going to have 6 minus 1 half, which is 5.5. Let's do one more, 5.5. So I'm going to put 5.5 squared minus 35. That's going to be negative 4.75. And 5.5 times 2 is going to be 11. So I'm going to have 5.5 minus a negative 4.75 over 11. So my new guess would be 5.9318. Make sure how many alterations did they want me to do. They wanted me to do 2. So I did 3 just because 5.5 wasn't close to my actual value. So if I do 3 alterations, I get 5.9318.